So next one we need to check the convergence or divergence for summation n equal to 1 to infinity e power 1 by n square. So we have f of x equal to e power 1 by x by x square. So f of x is positive, and it will be continuous. The only discontinuity is x equal to 0, so it will be continuous for x greater than or equal to 1, and as n is decreasing, so both the values will be decreasing. So if we have e raised to, so f of x is e raised to 1 by x by 1 by x square. So both are decreasing functions. So as x is decreasing, e power 1 by x decreases, and 1 by x square is also decreasing. So this will be decreasing function. So therefore f is positive, continuous and decreasing whenever x is greater than or equal to 1. So we need to evaluate integral 1 to infinity f of x dx. So this will be integral 1 to infinity. So f of x will be e power 1 by x square dx. So we'll put u equal to 1 by x. So du will be minus 1 by x square dx, and as x varies from 1 to infinity, u also u will vary from, so when x is equal to 1, u will be 1, and when x is infinity, u will be 1 by infinity, which is equal to 0. So we will get integral 1 to 0 e power u, then 1 by x square dx will be minus du. So this will be the value. So the integral will be minus integral of e raised to u is e raised to u itself from 1 to 0. So we'll get minus e power 0, which is 1, minus e. So the value is finite. So therefore the series converges by integral test. So the series will be convergent in this case. Next one, we have summation n equal to 3 to infinity n square by e raised to n. So f of x will be x square by e raised to x. That will be x square e raised to minus x, and f dash of x will be, so this will be 2x e raised to minus x plus x square into derivative of e raised to minus x will be minus e raised to minus x. So we'll get e power minus x 2x minus x square. So that will be 2x minus x square by e raised to x. So when x is equal to 2, the value will be 0. When x is equal to 3, we'll get 6 minus 9. So x square increases at a rapid rate compared to 2x. So from 3 onwards, 2x will be less than that of x square. So this value will be negative when x is greater than or equal to 3. So therefore f will be decreasing. So since the derivative is negative, the function will be decreasing, and already the function is positive. X square by e raised to x is always positive, and there are no discontinuities, so it will be continuous. So it will satisfy all the conditions when x is greater than or equal to 3. So we need to evaluate integral 3 to infinity f of x dx. So that will be integral 3 to infinity. So we will get x square e raised to minus x dx. Now by using integration by parts, so we will get first function into integral of the second will be e raised to minus x by minus 1 from 3 to infinity minus integral of derivative of the first will be 2x into integral of the second is e raised to minus x by minus 1 dx. So here at infinity we have e raised to minus infinity, so the value will be 0, minus at 3 we will get 9 e power minus 3 by minus 1, then 2 will come out, so we'll get plus 2, integral 3 to infinity x e raised to minus x dx. So we'll get 9 e raised to minus 3 plus 2. Again, this integral has value. So first function is x. Integral of the second is e power minus x by minus 1 minus. So this will be from 3 to infinity minus integral of derivative of the first is 1 and integral of second is e power minus x by 1 dx. So we'll have 9 e power minus 3 plus 2. At infinity, e power minus infinity will be 0 minus at 3 minus 3 e raised to minus 3 minus integral of e power minus x is e power minus x by minus 1 from 3 to infinity. So we'll get this is equal to 9 e raised to minus 3 plus 2 times. So we'll have 3 e raised to minus 3, and here we need to apply the limit for this one. So plus 3 e raised to minus 3, then we can make it a plus here. So plus, again applying the limit, e power minus infinity will be 0. So 0 minus e raised to minus 3 will come. So 0 minus e raised to minus 3. So that will be 9 e power minus 3 plus 6 e power minus 3 minus 2 e power minus 3. So that will be 13 e raised to minus 3, so which is finite. So therefore the series will converge by integral test. Next one we have summation n equal to 1 to infinity 1 by n cube plus n. So f of x will be 1 by x cube plus x. So that will be 1 by x into x square plus 1. So this will be equal to a by x plus, now x square plus 1 is irreducible. So we'll get bx plus c by x square plus 1. So 1 by x cube plus x is equal to this. Now equating the numerators, we'll get 1 equal to 8 times x square plus 1 plus x into bx plus c. So we'll get 1 equal to ax square plus a, then bx square plus cx. Now equating the coefficient on both sides, so equating the constants, we'll get a equal to 1 and equating the coefficient of x on both sides, so c will be 0, and equating the coefficient of x square, a plus b must be equal to 0. So a is already 1, so b has to be equal to minus 1. So we'll get f of x equal to a is 1, so 1 by x plus b is minus 1, so minus x by x square plus 1, and c is 0. So this will be the this is f value. Now f of x, so f of x was x cube plus x, 1 by x cube plus x. So from there we can see that it is positive. So whenever x is greater than or equal to 1, it will be positive, and as x increases, f value is decreasing, so the function is decreasing, and the discontinuity is x equal to 0. So it will be continuous whenever x is greater than or equal to 1. So f is positive, decreasing, and continuous for x greater than or equal to 1. So we need to evaluate integral 1 to infinity f of x dx. So that will be integral 1 to infinity 1 by x minus x by x square plus 1 dx. Now integral of 1 by x will be log x from 1 to infinity minus so let us First evaluate this integral. So integral of x by x square plus 1. So if we use a substitution u equal to x square plus 1, so du will be 2x dx. So x dx will be du by 2u. So that will be 1 by 2 log u. So which is 1 by 2 log x square plus 1. So value of integral will be log x minus. So integral x by x square plus 1 will be 1 by 2 log x square plus 1 from 1 to infinity. Now this will be equal to log x minus. Now 1 by 2 can be taken as exponent. So we will get log root of x square plus 1 from 1 to infinity. So this will be log. Now using log a by b form, so we'll get log a x by root of x square plus 1 from 1 to infinity. So again for infinity we'll take out x from numerator and denominator. So this is going to reduce as 1 by root of taking x square outside, that will become x. So we'll get 1 plus 1 by x square from 1 to infinity. So at infinity we'll get 1 by root of 1 plus 1 by infinity will be 0. So we'll get log 1 minus log of, at 1 we'll get 1 by root 2. So log 1 is 0. So we'll get minus log 1 by root 2, which is a finite value. So therefore by integral test the series will converge. And next one we have the summation n equal to 1 to infinity n by n raised to 4 plus 1. So we have f of x equal to x by x raised to 4 plus 1. So it will be positive and it will be continuous whenever x is greater than or equal to 1. And if we take f dash of x will be, so we'll get x raised to 4 plus 1 whole square on the denominator, then x raised to 4 plus 1 into derivative of x will be 1 minus x into 4x cube. So that will be 1 minus 3 x raised to 4 by x raised to 4 plus 1 whole square. So when x is greater than or equal to 1, this will be negative. So therefore f is decreasing. So whenever x is greater than or equal to 1, it satisfies the three conditions. So it is positive, continuous and decreasing. Now we will evaluate integral 1 to infinity x by x raised to 4 plus 1 dx. So let me write it as x dx by, so we can write this as x square whole square plus 1. So then we use a substitution u equal to x square. So du will be 2x dx, and u will vary from again 1 to infinity. So we will get integral 1 to infinity. So x dx will be du by 2, and here replace x square by u. So we will get u square plus 1. So that will be 1 by 2. So integral will be tan inverse of u from 1 to infinity. So that will become 1 by 2. Now tan inverse of infinity will be pi by 2, and tan inverse of 1 will be pi by 4. So we will get 1 by 2 times pi by 4, so which is finite quantity. So therefore the integral converges. So the integral converges. So therefore by integral test the series also converges.